All right, so here we go. Test 3 review. All right, y'all. So the first two questions on here deal with our end behavior chart. So we want to find the end behavior of the following graph. All right, so they're giving us P of X equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 5. Now remember, for the end behavior, I'm going to be using this chart where the degree is even or odd, and the lead coefficient can be positive or negative. So for my problem, my degree is 6. That's my highest exponent, which means my lead coefficient is that negative pi. So let's go down here when we're even degree and negative lead coefficient, both ends will go down. So for number 1, you want to choose the diagram where both ends are going down. Now, number 2 is the same thing. Choose the end behavior. That best describes the function. All right, y'all, this function, they got f of x equals negative 4.3 x to the 4th plus x to the 6th plus 0.9 x to the 7th. So y'all, the same thing. Notice on this number 2, though, they got it out of order. So my degree is actually the highest exponent, which is the 7. And my lead coefficient is that positive 0.9. So I got a odd degree and a positive lead coefficient. So on my chart, odd degree, positive lead coefficient will be the top right. So it's going to go uphill, left to right. Okay, so that's the trick on the first two, is to use that chart and figure out what your end behavior is going to look like, okay? Now, number 3, we're going to start finding zeros for the next 3 problems. So they want me to find the zeros and multiplicity. All right, y'all, so they're giving me f of x equals x squared minus 9 to the 5th power. So your zeros are going to come from the factors inside the parentheses. The exponent 5 on the outside, that's going to be our multiplicity, because that's how many of these parentheses would be multiplied by themselves. So the 5 is our multiplicity, and we'll get our zeros from the factor. So to find our zeros, we're going to take x squared minus 9 and set that equal to 0. All right, y'all. So you could factor this or square root it. I'm going to do square roots because they're sort of quicker. So to do the square roots, I'm going to add 9 to both sides. And that'll give me x squared equals 9. Then I'm going to do the square roots to both sides. Now, since I'm taking the square root of a number, I'm going to use the plus or minus to represent both answers so that I get x equals a plus or minus 3. So my zeros are going to be plus or minus 3. Each has a multiplicity of 5. Okay, so the zeros come from the factors, multiplicity by the exponents. Y'all, same thing on this, and find the zeros and multiplicity. So for 4, they're giving me f of x equals -2 times x minus 3 to the 4th, x plus 4 squared, and then x to the 3rd. All right, y'all, so the zeros will come from the x minus 3 factor, the x plus 4 factor, and the x factor. This -2 does not have a variable, so it will not give us a 0 out of that -2. So technically, we can get rid of that -2. What we got to do is set these 3 factors equal to 0, the x minus 3, the x plus 4, and then the x. Now, when we solve them, the multiplicities will be the 4, the 2, and the 3. So let me solve the first 2 by adding 3 to the first one. I get a 0 of 3. The second one, I'll subtract 4 and get a 0 of -4. And then this one, you can't do nothing to, so I get a 0 of 0. Now this one, we're going to fill in the blanks. So the 0, 3 has multiplicity blank. Then it says blank is a 0 of multiplicity 2. And then I got the remaining 0 is blank. It has multiplicity blank. All right, so let's start it out. 0, 3 has multiplicity blank. Well, here's my 0, 3. It came from the x minus 3 factor, and the x minus 3 factor has a multiplicity of 4. So the first blank, we're going to put our 4. Then it says blank is a 0 multiplicity 2. Well, the multiplicity 2 is the exponent following the x plus 4 factor. So we go down here where we solve the x plus 4 equals 0, and we got -4. So that means -4 is a 0 of multiplicity 2. That means the remaining 0 is 0. And it had a multiplicity of 3. So y'all on that one, just find your zeros and then just fill in the little questions they're asking, okay? All right, so I'll give y'all a second to catch up, and then we'll do the 4-term polynomial. All right, y'all, so let's start number 5 here. All right, so number 5, same thing, find the zeros and multiplicity. But y'all, this time they're not giving us one that's already factored. They're giving me a 4-term polynomial. X to the third minus 5x squared minus x plus 5. Now, I'm not going to lie. Y'all's polynomial will look exactly like mine. The only thing different will be the 5s. Y'all might not have 5s. Y'all might get 7s, 3s, or any other number. But everything else will be the same, okay? So what we're going to do, we'll set that equal to 0. So to factor these 4-term polynomials, that's the ones where we did the grouping. I grouped my first 2 terms together and my last 2 terms together. And we're going to factor out the greatest common factor from each of these 2 sets. So the first 2 terms got an x3 and a 5x squared. The greatest common factor between these 2 is the x squared. They both have at least the x squared in them. So you're going to factor out the x squared. And then you're sort of dividing both of these by the x squared to see what's going into parentheses. So that x to the third divided by x squared will leave you an x minus the 5x squared. When we divide by the x squareds cancel and leave me the 5. Now, the second GCF, we're going to put a sign in front of it, and it gets the same sign as this third term here. So since that x is negative, my second GCF will be negative. All right, now we got to see between an x and a 5, the only thing that we can factor out of that is a 1. So we're dividing both of these by -1. So negative divided by negative makes that a positive x. And then that 5 divided by negative makes that a -5. All equal to my 0. But y'all notice these parentheses match now. So we're technically going to factor out another greatest common factor between these 2 terms. And that's going to be the x minus 5s. So if we factor out an x minus 5 from both of these, x squared times x minus 5 divided by the x minus 5 will leave you the x squared. And then the -1 times x minus 5, if you divide that by x minus 5, you get the -1. So it's sort of like the 2 things in parentheses make up 1 parentheses on the final answer. The 2 things on the outside make up this second parentheses. So now we've got it factored. So now we'll solve each of these factors for the zeros. So I'll set the x minus 5 equal to 0. And then I'll set that x squared minus 1 equal to 0. So y'all, for the first one, we'll add 5. And again, x equals 5. The second one, I'm just going to add 1 and do my square roots to it. So I get x squared equals 1. And then let's do the square root. And remember, that'll be a plus or minus square root of 1. So that this gives me my x. And that's going to equal a plus or minus. We all square root of 1 is 1. So my zeros will be 5, plus 1, and negative 1. Now the multiplicities are going to be determined by what exponents are following these parentheses. So y'all remember, if there's no exponent shown behind these parentheses, we treat it like a 1. Okay, so I got one of these factors and I got one of these x squared minus 1 factors. All right, y'all, so this one, the zeros will be 5, 1, and negative 1. Each has a multiplicity of 1. So y'all ain't gonna lie. Y'all's problem will be just like mine other than these 5s. So you'll probably get a plus or minus 1 for these zeros. And the only thing different will be that 5 on those, okay? All right, y'all, 6 is a true or false. If P of X equals X minus 9 to the 6th times X plus 3 to the 7th, then the graph crosses the x-axis at 9, 0. So we want to know if this is true or false. Now, what I'm using on this is the fact about these multiplicities here. I got an even multiplicity 6, and this one has an odd multiplicity 7. Remember, factors that come from a even multiplicity, if a factor has an even multiplicity, it's going to be tangent to the x-axis. If it has a odd multiplicity, it's going to cross over the x-axis. Okay, so evens will be tangent, odd multiplicities will cross over it. So I got my x-intercept is 9, 0. Remember, the x value of the x-intercept is the same as the 0. So I got to figure out which one of these factors that 0 came from. Well, it had to come from the x minus 9 factor. So if you said x minus 9 equals 0, you would get x equal to 9. So I'm looking at the multiplicity on the x minus 9 factor. That multiplicity is a 6, which is even. So since it's got an even multiplicity, it should be tangent. But y'all, they're saying, hey, it crosses the x-axis. So this is false. Now you got to put the reason why. So the reason why this is false, because the exponent 6 is even. And since it's even, it should be tangent. Okay. So true or false, and then you sort of got to tell why. Now, the other false one would say false, the exponent 6 is odd. Okay, so that's how I really tell the difference. The correct one would have the exponent as even. The false one would have it as odd, okay? All right, for number 7, Let me find my polynomial. All right, so 7, I want the max zeros. Then these are real zeros, so we want the maximum real zeros. Maximum real zeros, maximum x-intercepts, and then the maximum turning points. All right, y'all are giving me f of x equals 3x minus 5x to the 6th. So these three answers depended on the degree of the polynomial. And y'all, our degree is a 6. So the maximum real zeros, y'all, what is that answer? See if y'all remember these. Oh, y'all, let me let one in real quick. All right, y'all, so I'm going to refresh you. The maximum real zeros is equal to the degree. So since I got a degree 6, the maximum real zeros would be a 6. Well, the maximum x-intercepts, well, remember, x-intercepts are pretty much the same thing as zeros, okay? So since they're pretty much the same thing, that means for max x-intercepts, I will also have 6. So the one that's going to be different is the maximum turning points. If the real zeros equal 6, the maximum x-intercepts equals 6, the maximum turning points is the degree minus 1. So if I take 6, subtract 1, I get 5 from my turning points. So remember, equals the degree, equals the degree, equals the degree minus 1. All righty, y'all. Right, then you're going to get into a few graphing. So this wants me to sketch the graph. They're giving us h of x equals x times x minus 1 times x plus 1 times x minus 6. Okay, so on these 8 and 9, you want to adjust your calculator to the window that matches these graphs. So I will say this one. On this one, the x's go from negative 10 to a positive 10 on the graph. The y values go from negative 100 to a positive 100. And it looks like the x's are going by ones. The y values, there's 10 marks, so they're going by tens on them. So I'll set the scale for the x's at 1. I'll set the scale for the y values at 10. Now let's just get an idea of what we think this will look like. If you multiply all these 4 x's together, x times x times x times x, that's going to give us the x to the 4th, and it's positive because all these x's are positive. So you would have an even degree with a positive lead coefficient. So y'all, in the long run, Both ends of our graph should be heading upward. So let's go graph this and see what we get. I'm going to go to our calculator. I'm going to go to y equals, and I'm going to punch that in, x times parentheses, x minus 1. And then x plus 1. And then finally, x minus 6. Now remember, I'm going to adjust my window. So hit the window button, make the x's go from -10 to +10. And they're going by ones. The y's went from -100 to a +100. And that scale is going by 10 because it had 10 marks on it. And 100 divided by 10 would make that 10 each. So we got our equation in. We got the window set. So we're going to hit graph. And y'all, it sort of almost looks like a W in there. But notice both ends are definitely going up. Okay. So you would pick the graph where it's sort of coming down and going up, okay? And there'll only be one graph that even looks like that, okay? See, on 9's the same thing. They want us to graph this one. This one is a f of x equals 15x to the third minus 12x squared minus 135x plus 108. Now, going by the leading term, I'm going to sort of figure out what the end behavior will look like. That's an odd degree with a positive lead coefficient. So when it's odd with a positive lead coefficient, it should go uphill left to right, okay? Now, we're about to graph this one. The x's go from -5 to 5. The y values go from -250 to a +250. So now I will say on this one, you got to be careful because two of these graphs are really, really similar on their answers, okay? So let's go graph that. So I'm going to go to y equals and clear that out. All right, y'all. So we had 15x to the third. All right, now arrow back down and put in minus 12x squared minus 135x plus 108. All righty, now let's go set that window. So my x's went from -5 to a +5. And I'm going to keep them going by ones. My y minimum went from -250 to a +250. And I'm going to go by that. 250 divided by 10 would make these each 25 in between. So we got our polynomial in, we got our window set. So y'all, let's graph that. So notice it does sort of go uphill left to right. Which is what we predicted, okay? Now I'm going to show you something on this one. When you look for the picture on this one, remember, ours has a little bit of space right here. They have another picture where the graph comes up and it goes right through the center, then goes up. Okay, so beware of that. You don't want the one where it's going right through the center. You want the one that's got that little bit of space in there, okay? So I just reminding you on that, because if you're going pretty quick, you'll see that shape and you might grab the wrong one, okay? So make sure yours has that little bit of space in it. All right, y'all, then we start getting into a little synthetic division. So starting in that 8.4 section here. So for 10, using synthetic division, determine if the numbers are zeros. Of the polynomial. All right, so they're giving me a -1, 1. So these are the two numbers we're going to check. And our function is h of x equals x to the 4th plus 4x to the 3rd plus 3x squared minus 6x minus 2. So using synthetic division, we're going to write our coefficients down and nothing's missing. So the x4 gives me a 1. I get a 4, a 3, a -6, and a -2. The first number I'm going to check, and you got to go in order, is that -1. So let me see if y'all remember this. If -1 is a 0 of this polynomial, what remainder should y'all get? Well, it's crickets today, ain't it? All right, y'all. So if -1 is going to be a 0, I hear that the cold front got y'all today. Okay, so so y'all, if that's a 0, then my remainder will be 0 on that, okay? If I get anything other than a 0, we're going to put no. All right, y'all, so bring that 1 down and then start multiplying. 1 times -1 is -1. Add that column together, you get 3. 3 times -1 is -3. 3 and -3 give me 0. 0 times -1 is 0. -6 and 0 give me -6. And then finally, that -6 times -1 gives me a +6. So y'all, that was giving me a remainder of 4, which is not 0. So this would be no. -1 is not a 0 of this polynomial. So let me try a +1. Now my numbers will be the same. 1, 4, 3, -6, and -2. All right, y'all, same thing. Bring this one down. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 3 plus 5 is 8. Right? 8 times 1 is 8. -6 and 8 give me a 2. And look here, 2 times 1 is 2. And that gives me a 0 remainder. So it looks like y'all got yes on that one. So y'all, since I got a 0, that is true. That is definitely a yes. So I've seen this one go yes, no for the answers, no, yes for the answers. I've even seen a yes, yes, but I've never seen a no, no. So at least one of y'all's will be a yes on that, okay? All right, y'all, suppose a degree 4 polynomial has some of the zeros of a I and a 4 minus square root of 5. So some of the zeros are I and 4 minus square root of 5. They want to know, what are the other zeros? So think about it. It's a degree 4, so it's going to have 4 zeros. They're giving me 2 of these. So the other 2 zeros, well, y'all, here's one thing. I get a negative I, good job. And then 4 plus square root of 5, definitely good job. Good, the i's come in conjugate pairs. So positive I, negative I. The radical parts come in conjugate pairs. Now notice, we didn't change the sign of the 4. We only changed the sign of the radical part, okay? All right, so that's the trick on that, and is to realize these always come in conjugate pairs. Because knowing this is going to help us on number 12, okay? So let's pull over for number 12. All right, so remember what we just learned on number 11. So number 12 says find the polynomial of lowest degree that has a square root of 3 and a 5i as some of its zeros. So this is where we had to come in and foil until we came up with a polynomial. They're not telling me what the degree is going to equal because they don't want to give away the problem. So since these are zeros, remember, those are like the solutions. So this is where I came in and said, okay, x equals the square root of 3. But y'all, if x equals square root of 3, if square root of 3 is a 0, then automatically a negative square root of 3 has to be a 0. Now, if x equals 5i is a 0, well, y'all, that means x equals a negative 5i also has to be a 0. So they weren't giving away the problem because of the lowest degree part, but they wanted you to realize that these always come in conjugate pairs. All right, so we start out with our solutions. Next, we want to get a 0 on the right side. So we're going to subtract and add as needed. So I get x minus square root of 3 is 0. I'll get x plus square root of 3 equals 0. I'll get x minus 5i equals 0. And then finally, I'll get x plus 5i equal to 0. All right, so we've got 4 equations equal to 0. We're going to write that as a product, all equal to 0. So x minus square root of 3 times x plus square root of 3, x minus 5i times x plus 5i, all of this equal to 0. All right, so basically we got a lot of foiling. So I'm going to foil the conjugate pair stuff together on each side of this. Okay. Now, since these are conjugate pairs, we're going to shortcut. We're going to multiply the x times x and get an x squared. A negative square root of 3 times a positive square root of 3. Well, that's going to be a negative. Now, a square root of 3 times square root of 3 is a square root of 9. But y'all remember, a square root of 9 is a 3. So when you multiply square root of 3 times the square root of 3, you get a 3. Okay, a radical times itself gives me that number. Now we'll shortcut this one. X times x is an x squared. Now let's see what we get here. A negative 5i times a positive 5i. That is going to be negative 5i times 5i is a negative 25i squared. Well, y'all, what does the negative 25i squared turn into? So you just got to remember what that little I squared equals. And that's right, that's a positive 25. Because I squared equals negative 1. And negative 1 times negative 25 equals a positive 25. Perfect. There you go. So that's going to be a positive 25, all equal to 0. So y'all watch this. The radicals, conjugate pairs of radicals, always end up being subtracted. Conjugate pairs of imaginary numbers always end up being added. All right, y'all. Now, we get to foil these two things together. And these are not conjugate pairs, so I got to foil everything. So the x squared times x squared gives us x to the 4th. X squared times 25 is a 25x squared. Negative 3 times x squared is a negative 3x squared. And y'all, finally, the negative 3 times 25 is a negative 75. All right, y'all. So the only thing we got left is to add like terms in the middle. So bring down your x4. 25 minus 3 leaves me 22 x squareds minus my 75. So MATLAB, all MATLAB wants, they're going to have the f of x equals. All we're doing is putting in our polynomial. X to the fourth plus 22 x squared minus 75. So y'all, they just want the polynomial there, okay? So that's the only one you had to do all the foiling on, but you got to remember that these are coming in conjugate pairs, okay? Ooh, y'all, 13. Let's see. The polynomial has the given 0. It wants us to find the other zeros. Okay. So let's see. My polynomial is f of x equals x to the third plus 6x squared minus 3x minus 18. And the 0 they're giving us is a negative 6. All right, y'all. So they're giving me 1 0. This has a degree 3. So that means there's 3 zeros total. They're giving me one of them. So we got to find the other two. So what we want to do, we want to start out doing synthetic division with that negative 6. And then once we get our quotient, we'll use the quotient to get the other two zeros, okay? So let's start out with our negative 6. All right, my numbers will be 1, 6, negative 3, and negative 18. So let me see if y'all remember this. If they're giving me negative 6 as a 0, y'all, by God, that remainder better be what? And if it ain't that 0, good job. If we don't get a 0 here, we made a mistake. Because anytime they give you a 0, that means we better get a 0 remainder. Now, what we're looking for is these three numbers right here, okay? So let's see what we're going to get. We're going to bring our 1 down. 1 times negative 6 is negative 6. 6 and negative 6 will give us a 0. 0 times negative 6 is 0. Negative 3 plus 0 is negative 3. And y'all look at that. Negative 3 times negative 6 is 18, which gives us a 0 remainder. So, but we knew that. Now, these are the numbers I'm worried about. So if you used to write this as a polynomial, since that was an x to the third, this is going to start 1 degree less. So that means I got 1x squared plus 0x's minus 3. So there's the numbers I'm going to use, and I'm going to set that equal to 0. Oh, you also remember, I'm going to add 3 and do my square roots to this. So I get x squared equals 3. I'm then going to square root both sides. So that'll be a plus or minus square root of 3. So that gives me my x. And y'all, guess what? I can't do anything with that square root of 3 because that's not a perfect square. So that's just going to give me a plus or minus square root of 3. Now, here's what MATLAB wants. It wants the other zeros. It doesn't want us to put the -6 because they gave us that one. What they want is the plus or minus square root of 3 on that one, okay? Or you can put what? Square root of 3, comma, negative square root of 3. Either way. So it'll take it like that. Or like that, okay? All right, y'all. Then it started getting into some domain stuff. All right, so let me fix this paper. So for 14, they want us to find the domain. And y'all really, 14 and 15 will be doing the same thing, except 14, they want us to write the answer in set builder notation and interval notation. All right, y'all. So this one has f of x equals x to the third minus x squared plus a x plus 3 all over x squared plus 9x plus 18. So since it's a domain problem, I'm going to take the bottom of this fraction, set it equal to 0. Okay, so remember, domain, all we're worried about is something making this thing undefined. All right, x squared is an x and an x. Last one's positive, so both of these factors will be positive like that 9. And let's see, I'm wanting factors of 18. That'll add to get me a 9. And that'll be what, a 6 and a 3. All right, set both of these equal to 0. So y'all, the first one, I'm going to subtract 6. And I get x is a -6. The second one, I'll subtract 3 and get x is a -3. So these are the two numbers I got to kick out. Now, they want these answers in ascending order. So they always want the smallest number first and then the larger number. So this would be x such that x is real number. And x cannot equal -6, and x cannot equal that -3. Okay, so pick the one where they give you the two options to put in both numbers. But remember, y'all, have the smaller number first, followed by the larger number. And then interval notation will be, you're going to start at -infinity till you hit the first number, -6. You're going to union around -6 till you hit the second number, -3. We're going to union around -3 and head off towards positive infinity. So remember, the curvy parentheses mean we don't include these numbers, so that's why we got a union around both of them, okay? All right, 15, same thing, but we only got to write this answer in interval notation. So find the domain. So this one would have came out of 5.1 and this one would have came out of 8.5. All right, y'all. So I got f of x equals -2 on top over x squared plus 3x minus 28. All right, y'all. So domain again, set the bottom equal to 0. So 14 and 15, you're working exactly the same way. The only thing different is the factoring. That one had a plus at the end. This one has a negative at the end. So x squared is x and x. The last sign's negative, so you got one negative and one positive. And it don't matter what order you put these in. You could put the plus here and the negative here. Okay, that don't matter. What matters is if you got the right number with the right sign, okay? So I want factors of 28. That'll subtract and give me 3. That'll be 7 and 4. The larger number has to be positive like the middle. So 7 is larger, it'll be positive, and then the 4 will be negative. And if you add that, 7 minus 4 is a 3, okay? Now, finish solving this. And you'll know, when we're setting all these factors to 0, all we're doing is changing those signs from a negative to a positive, and then from a positive to a negative. You know, we'll get an x plus 4, an x equals positive 4, and then x equals a -7. So remember, I got to go in order. So interval notation will start at -infinity. It's going to hit -7 first. So union around -7, then we'll hit the 4. So we'll union around the 4 and then head off towards positive infinity. Okay, so that's the trick on those two, is just worry about that denominator only on those, okay? All right, y'all, so I'm going to turn over. We're going to start getting into the asymptotes now. So let's see. This is 16.
Hey, I didn't get a chance to write that down. My bad.
Okay, I got you back. Just tell me when you're ready. And so yeah, 16, we start getting into the asymptotes. We got the vertical asymptotes and the horizontal. Now, 16 is going to ask about an oblique asymptote. We're going to put no oblique on that one, okay? So nobody will have a oblique asymptote.
You're saying on our test, Mr. Rathon, that we won't have any oblique asymptotes?
True.
Okay.
Yeah, and I'll sort of, it's going to ask for it on 16, but just put no on that one, okay? Right, y'all ready for me to go, or?
Yes, sir. I'm good.
Okay. All right, y'all. So 16 lists all asymptotes. And we'll choose which graph. So my function is r of x equals 3 over x squared minus 4. All right, y'all. So I'll start with my vertical asymptote. I'll find those by setting the bottom equal to 0. Whoops. x squared minus 4 equals 0. I'll solve that for the x's. That'll give me my vertical asymptotes. So y'all, I'm just going to solve this by adding 4 to both sides. So I get x squared equals 4. And then I'm going to do my square root. That'll be a plus or minus square root of 4. So that x equals a plus or minus 2. Now, Math Lab's a little picky on this one. So on this one, for 16, you actually can't use the plus or minus. On 16, you got to put x equals 2, comma, x equals negative 2. And you got to write those as an equation, okay? So next, it would ask you for an oblique asymptote. On that one, put no oblique asymptote. Okay. Now the horizontal asymptote. The horizontal asymptote is when I compare the degree of the top to the degree of the bottom. Well, the bottom has a degree 2, because that 2 is following that x, and that's the highest exponent on bottom. So the bottom is a degree 2. The top does not have a variable. So the top is a degree 0. So degree 0 on top, degree 2 on the bottom. So the bottom is greater than the top. So when the bottom degree was greater than the top degree, oh boy, y'all's chat done got it. Yeah, the bottom's greater than the top, then it's going to be y equals 0. Now, I'm not going to lie. I'm pretty sure everybody's number 16 is going to come out to y equals 0, okay? Because I haven't seen a 16 that has a variable in the top. So the only difference on this part y'all should get is maybe what these two numbers right here are, okay? Now, let's just sort of play with this a second, and then I'll show you how to graph it. I'm just going to play with this a second. So since my vertical asymptotes are at 2 and negative 2, so here's 2, and here's negative 2, you should have asymptotes at the 2 and the negative 2. Okay. Now, let's graph this, and then we'll look at our pictures. Now, let me say on this one, their windows are going from negative 4 to 4 on the x's. And the y values are going from negative 3 to a positive 3. So I'm going to set my calculator window to these x and y values, okay? So let's go to the calculator. I'm going to clear this off. So do you remember how, what I did to put this in as a fraction? Y'all remember I hit the alpha, the green button, and the y equals, and then I'm going to hit enter for ND. So now on top, we had a 3. And then I'm going to arrow down, and we had an x squared minus 4. All right, now I'm going to hit my window, remember, because these were from negative 4 to 4. And then my y's are going from what I have, negative 3 to a positive 3. And I'm going to change that scale from 25 back to 1. All righty, y'all. So everything's set back. Let's hit graph. So notice you can tell on the left side where the vertical asymptote is and on the right side. And then it looks like the middle part looks like an upside down parabola almost. So y'all, let me go back. So we want the one where it's sort of upside down in the center. Now what they'll do, they'll make one where it's right side up. And then I've seen them where they change the asymptotes up. Okay, so watch really careful. Make sure you got both asymptotes and you're shaped right in that center part, okay? All righty, y'all. 17 wants me to determine the vertical asymptotes. They're giving me g of x equals x to the third on top over 2x to the third minus x squared minus 10x. So I'm not going to lie, this is probably one of the trickier problems you're going to do. And it's because you're going to get one of your asymptotes to cancel out. So let me show you how that's going to happen. So first I will set the bottom equal to 0. So y'all, the first thing you got to do to factor this is factor out that greatest common factor of the x. So you would factor out 1x, which would leave you a 2x squared minus x minus 10, all equal to 0. Now, y'all, at this point, this x is going to cancel out because look on top. You got an x to the third. Remember, x to the third is x times x times x. So since I got a factor on the bottom that matches a factor on the top, this x right here is going to cancel with one of those x's on the top. So that means it will not give me a vertical asymptote. What it would do, it would make a hole in the graph at that point, okay? So that one's gone. So what we got to figure out is these two asymptotes that we're getting from what's left. So the 2x squared minus x minus 10, I'm going to set equal to 0, and I'm going to solve this by factoring. Now, x squared is still going to give me an x and an x in the front. The last sign is negative. So one of these will be positive. One of these will be negative. So everything's still the same as far as the signs and the front of these being the x squared. Now to get the numbers, watch what I got to do. Since I got this 2 in the front, I got to take that 2 and multiply by that 10. So 2 times 10 gives me 20. Now, I don't care about the sign, y'all. I'm just multiplying the numbers. So anytime you got a number in front, multiply by the last number and get that product. Now, find factors of 20. That'll give you a 1 in the middle. So find factors of 20 that give a 1. And remember, they're going to subtract. because the last sign's negative, you find factors that subtract. If the last sign was positive, you'd find factors that add. All right, so Timothy got a 5 and a 4. Perfect. The 5's larger at this point, so it's got to have the same sign as the middle. So the 5 will be negative, and the 4 will be positive. But y'all, we're not done yet, because here's what we got to do on this one now. Since I borrowed that 2 and multiplied by the 20, multiplied by the 10 to get to 20, we now got to divide both of these factors by that 2. So it's like you're borrowing the 2. You're going to multiply it, find your 2 factors, then you got to divide by that 2. So now divide both of the factors by the 2. Okay. Now, try to simplify these. We on the first one, 4 divided by 2, that gives me a 2. Well, guess what? Can't do nothing to that one. So that's going to stay x minus 5/2. And remember, all this stuff is still equal to 0. All right, y'all, so let's get those asymptotes now. Set both of these factors equal to the 0. All right, also here, subtract 2. So my first vertical asymptote is x equals -2. My second one, I'm just going to add 5/2. And that one will give me x equals a positive 5/2. So let's see. Now be careful on this one. This one already has the x equals. All we're going to do is put in our 2 numbers and separate that with a comma. So you would put in your -2, comma, 5/2. And be done. So y'all, you got to look at the answer blanks. Do they already have the x equals? Okay, so this one did, so I just put in the 2 numbers. But remember on this one right here on 16, I had to write them as both equations because they didn't have the x equal part. Okay, so be careful and look at them answer blanks. But those should follow pretty much what we're doing here, okay? All right, I'm going to give y'all just a second there. All right, y'all, so look at that. 17, we just got 3 to go. So here, whoops, here we go. So y'all, 18. Determine the horizontal asymptote. Okay. Whoops. My camera's all wacky there. There we go. All right, so determine the horizontal asymptote. They're giving us f of x equals x squared minus 5 on top over 4x to the 4th plus 3. So if it's a horizontal asymptote, I'm looking at the degree of the top and the bottom. So my top is a degree 2. My bottom is a degree 4. So y'all, that means that the bottom degree is greater than the top degree. So let's see, y'all done got that one? Definitely it's going to be y equals 0. Now y'all, guess what? On this one, they already give you the y equals part. So all you're putting in is that 0. Okay, so 17 gave you the x equals. 18 is giving you the y equals. All right, y'all, then 19 and 20 deal with the inequalities with the less than, greater than. So they want us to solve the following inequality. So y'all, this one I got x minus 4 times x plus 2 less than 0. So this is where I set up the number line and I use the solutions that I get. So to get them solutions, I'm going to set x minus 4 equal to 0 and x plus 2 equal to 0. Once I solve these, I'll set up my number line, test, and see what's happening. So add 4 on the first one so that you get x is a positive 4. And then here we'll subtract 2 and get x is a negative 2. So for my number line, my two numbers, so let's see, negative 2 comes first, and then my positive 4. So 0. 0's got to be in between negative 2 and 4. So I'm going to test my 0 to see if this is true or false. If it's true, I'm going to shade that center. If it's false, I'm going to shade the outside edges. So y'all, let me put a 0 in and see what happens. So 0 minus 4, 0 plus 2 has to be less than 0. Well, y'all, this one's going to give me negative 4. This one gives me 2. So let's see, negative 4 times 2 is negative 8. Less than 0. So you got to determine whether that's true or false. So y'all, is that true or is that false? Is negative 8 less than 0 true or false? Y'all are still code. So there you go. It is definitely true. Good job. So since that's true, we would shade that section in the middle. Now, here's my question. Around these numbers, would y'all use parentheses or brackets? Oh, I finally got y'all on something. Look here. If there's not equals under here, so remember, I used brackets if it had equal under it. So since this does not have equals, y'all would use parentheses. Okay. So I just do that so that you can get your interval notation right for your final answer. So the final answer, you got parentheses around that negative 2. And it goes to 4 and parentheses. So y'all remember, greater than equals or less than or equals, we use brackets. If it's greater than or less than, we use our parentheses, okay? Alrighty, now MathLab just wants this, and it's got to be written with those parentheses, okay? Because it's interval notation. All right, y'all, the last one said solve x squared plus 13 is less than 2x. So to solve this, I need a 0 over here. So I'm going to subtract 2x from both sides. So I get x squared minus 2x plus 13 less than 0. Alrighty. So now we're going to try to factor that and set everything equal to 0. So x squared is an x and an x. The 13 is positive, so I got like signs. And both of these will be negative like the middle. All right, y'all. Factors of 13, that'll give me a 2. Well, hell, we ain't got one guess on that one because 13 is a prime number. So 13 times 1 is the only option I got. But that 13 plus 1 does not give me a 2. So y'all remember, since I can't find factors of 13 that give me 2, this one does not factor. So remember, since this one does not factor, my answer is no solution, or what we call the empty set. Okay, because there's no answers that make that true. So, wow, and everyone that I've done on number 20 has ended up with that answer, okay? So, I'm not going to say 100% because one of y'all might get a curveball and have something that actually factors. But if you can't factor it, don't worry. It's probably one of those that does not factor, okay? All right, y'all. Oh, that's number 20. So that is the study guide. So let me go back to my, everybody got it? All right,
Got it.
all right, I'm gonna stop that share then. So y'all,